welcome to the next session on ANSYS Workbench tutorials. In this session, we are going to analyze the Gudgeon pin for its static structural analysis. If you have observed this diagram, this piston pin fits into this connecting rod and also it is attached to the piston head. So if you observe carefully, when the piston head moves up and down, this piston is going to be subjected to a pull by this connecting rod. This connecting rod will apply pressure on this piston pin, because of which there can be a failure. So we are analyzing this piston pin for its static structure analysis. We will start by double clicking on static structural. Next, I'll go to engineering data. I'll enter the material, that is alloy steel. The first property to be allocated is density, that is 7700 kg per meter cube. Next value to be allocated is the isotropic elasticity. This value is 2.1 E11 Newton per meter square. So here it is Pascal. Value of Poisson's ratio is 0.28. Apart from this, you can give the value of tensile yield strength, that is 6.2 E8 Newton per meter square. Also, if you want to add the value of ultimate tensile strength on the body, the value is 7.23 E8 Newton per meter square. So now I'll go to project, update project. I'll go to geometry and directly import the geometry. Then I'll go to model and double click on it. First, I will allocate the material, that is alloy steel. Then I'll go to mesh and I'll change the sizing to fine and update. Next, I'll go to static structural, and on both the sides, since there is circlips attached, so this will be fixed. So this is fixed and so is this end. Now on this surface, I am going to insert pressure. To say the value is 7 bar pressure, which I have taken from some research paper. So I am giving the value here as 0.7 megapascal. You should apply this pressure mainly at this zone, at a strip. So what you can do is, here you can create a small zone and then you can apply this pressure. If you apply the pressure on this entire surface, and the entire surface will show you a result. So you can just select a zone over here and create the pressure. So we have closed the model. Now we have to go back to geometry and double click on it. So now I'm going to split this body so that I can apply pressure. I'll click on split option. I'll click here once so that I know its distance. So I want to apply load over a patch of say 30 mm. So I have given this patch on this body. Now once this is done, we will go to model and double click on it. It is asking if you want to read the upstream data. Click on yes. So you can see here this patch has been obtained. Now I will click on fix support once again and I'll give the boundary conditions because they just get removed as you have changed the geometry. So this is the surface for the fixed support 2 and I'll apply pressure on this zone. Apply. Okay, you can see the mesh has also been removed. So you can just click on it once again and update. Next I'll go to solution and I'll insert deformation total. I also want to see the stress over the body, the equivalent stress, the equivalent strain. In tools, I will click stress tool so that I get the result of safety factor. Also, I will choose fatigue tool for this body. I will give the mean stress theory as the Gudgeon theory. Then I'll right click and insert life. Also right click and insert damage. Go to solution and solve once again. So now you can see here, this is the total deformation over the body. You can animate and see the result. Though this looks like a lot of deformation, the value is not so. You can check the value, it is 0.000356 mm, which means the value is really small. Next, you can go to equivalent stress and again animate and see the result. The maximum value of stress is 4.74 megapascal. The value is really small because we have given the material as alloy steel, and the minimum value of stress on the body is 0.1467 megapascal. We'll check the strain. It is 2.3719 into 10 raised to minus 5. So this is really small amount of stress generated on the body. You can animate and see the result. Though this looks like a lot of strain generated, but it is not so. You can click on safety factor and see that the value of safety factor throughout the body is 15, which means your body is completely safe. The most important part is fatigue tool. This will help you understand the life of this piston pin. It is 1 into 10 raised to 6 cycles, which means the piston pin will be completely safe under this amount of load applied on it. With the help of this damage, you will understand that the piston pin is designed for 1 into 10 raised to 9 cycles, but it is going to work for only 1 into 10 raised to 6 cycles given the boundary conditions. So here you have done two types of analysis. One is static structural analysis. Also you have done the fatigue analysis of this body with the help of the fatigue tool. So I have just clubbed both of them under the same heading of structural analysis. So with this I end the session. I hope you have understood the analysis. If you have any doubts, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.